Hi, welcome to Seshu Solutions. Today I'm going to teach you about prime factorization. First example, if we have a number 50, 50 is an even number. We can write it as 2 times 25. 25 we can write it as 5 and 5. Now 2, 5 and 5 are prime numbers. We can write the answer as 2 times 5 times 5. We can write it as an exponents 2 times because we have two fives. We can write it as 5 to the power of 2. Okay. Coming to the second example, 90. 90, we can write it as 9 times 10. But 9 is not a prime number. It has factors. 9 has 3 and 3 as factors. 10 is 2 and 5. Now 3, 3, 2 and 5 are all prime numbers. 90, we can write it as 2 times 3 times 3 times 5. We have to circle the final answers and then we have to write the numbers from least to greatest. The least number is 2 and then we have 2 threes and then 5. 90 is equal to 2 times 3 to the power of 2 times 5. This is the prime factorization for 90. Third example, 96. 96 is an even number. We can write it as 2 times 48. 48 is again an even number. 2 times 24. 24 is again an even number. 2 times 12. 12 is nothing but 2 times 6 or 2 times 3. Now circle the number of 2's we have. How many 2's we have? 1, 2, 3, 4, 5. We can write the answer as 2 times 2 times 2 times 2 times 2 5 times and then 1 3. Or we can also write it as 2 to the power of 5 times 3. Okay, this is one method, or we can do another method also. 96, right? 2 times it is 48. Again, it is divisible by 2. 2 times 24. 2 times 12. 2 times 6. 2 times 3. So how many 2's we have? 1, 2, 3, 4, 5. 2 to the power of 5 times 3. Okay. Fourth example, 108. 108. 108 is an even number. We can write 2 times 54. Again, 54 we can write it as 9 times 6. But 9 is not a prime number. It has factors. So we have to do 3 and 3. Now 3 and 3 are prime numbers. You can leave it here. 6 is again 2 times 3. Now circle the numbers. What are all the prime numbers that ended the tree? Which is 2 times 2 because we have 2 2's and 3 3's. Which is 2 to the power of 2 times 3 to the power of 3. And if you want to do another method here, 108. In this method, it always try to divide it by only the prime numbers, okay? 54, right? Again, this is an even number. It is divisible, 27. In 27 will not come in the 2 table. So 3 times 9 and 9 again 3 times 3. Like 2 times 2 and we have 3 threes. 2 to the power of 2 times 3 to the power of 3. Okay. Fifth example, 144. Whenever you see 144, most of the kids will do 12 times 12. But we can't stop it here. We have to do 2 times 6 because 12 has the factors. It's not a prime number, so you can't leave the answer like that. Again, 12 is 2 times 6, 2 times 3, and 2 times 3. Now, circle where the tree ended, okay? How many times we have? 3 twos. So 2 times 2 times 2 and 2 threes, 3 times 3. We can also write it as 2 to the power of 3 times 3 to the power of 2. The last example, 210. Because 210, it's divisible by 10, right? You can write 21 times 10. But 21 has factors. What are they? 3 and 7. And 10 has a factors 2 and 5. They are ended with 2, 3, 5, 7. 2 times 3 times 5 times 7. Okay. But if you do this method 2, 10, we always has to, should not divisible by 10 because 10 is not a prime number, right? So we have to divisible by 2. 2 times 105. Now this is divisible by 5. 5 times 21 because 5 is a prime number. 3 times 7 is 21. Now 2 times 5 times 3 times 7 we can write, but rearrange the numbers from least to greatest. 2 times 3 times 5 times 7. Okay. What are prime numbers? Prime numbers are that are multiples of itself. What are the prime numbers? We have 2, 3, 5, 7. Most of the kids will say 9 is a prime number. 9 has factors. Prime numbers are multiples of itself. Okay. So 9 is not a prime number. 11, 13, 17, 19. Okay. 23. 29 like that. Okay, prime numbers are numbers that are multiples of itself. One is neither prime nor composite. Okay, I hope I gave you a clear idea about prime factorization. Thank you so much for watching. If you like this video, please like, share and subscribe.